got help from someone in here and they're nice, get their number. Right? If somebody like has the ability to, and some of you have taken discrete math. I'm sure how it looks like this. There we go. I don't know about this. How do I make this full screen? There we go. But I still didn't make this full. Not sure how to get that to be full screen. It's maybe a good time to talk about all the math you ever learned. So when you were very little, it depended on how good of parents you had that sat there and taught. Like with my son, again, you're going to feel sorry for him. You know, I have him work with these cubes and count them early. And, you know, I would tell him prime numbers or what they are and what, you know, what could be factors of something else. By the time I got to my third child, I didn't have time for that. And one day I realized she can't even count. So we started on Candyland, but we started with counting. So these are the counting numbers. And they are 1, 2, 3, 4, ... We also call them the natural numbers. Then one day, probably second grade, third grade, they started telling you about negative numbers. Z stands for the integers. And on all of this, like the best thing, like when you teach your own kids one day, it's going to happen. Like 10 years is going to go by, you're going to have your own kids. Number lines are really great things. You start with here, 1, 2, 3. And you teach kids how to add, because if you add two numbers on the number line, it stays on the number line, right? Subtraction becomes a problem. So you do teach subtraction to little kids, but then sometimes they transpose things. So if you're in my house and you did a 3 minus 5, we'd have a conversation like, hey, that actually can be done. You transpose, but let's go to your number line. It actually can be done. So one day you learn that, hey, the number line actually stretches like this. Dot, 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 both directions. And here now it's addition. Can we get attention back? Like we can finish the worksheets back again. Pay attention up front. So on this one is closed under addition. It's closed under subtraction. So if I add any two integers, I get another integer. If I subtract two integers, I get another integer. It's also closed under multiplication. So if I multiply two integers, I get an integer.
This might be a bad question, but what's the difference between a number you can count and
There's no negatives in the counting numbers.
no negative?
So subtraction is not, you don't have inverses, right? For it, you know, so on the natural numbers, you can add, but you don't have an inverse. An additive inverse is what we call it. For Z, you have additive inverses. And by the way, you can multiply too. On the natural numbers, you can multiply things. So 2 times 3 works, 1 times 5. You never multiply out of the natural numbers. Same with the integers. Multiplication works. You don't multiply out. Now subtraction works. Every integer has an additive inverse. -2, it's +2. So everything has an inverse. So you can do more on it. That's actually one place we start to lose children in math, is right when we start to show them negative numbers. Think around 4th grade. fractions too start showing up there. That's the next thing you learn. Rationals. It's closed under addition, subtraction, multiplication, and Q minus 0, throw out 0, it's closed under division, which is the inverse of multiplication. Another place every time we introduce one of these things, we lose kids. And then the next place you lose kids is when you introduce the real numbers around 7th grade. You actually see this dip in national testing right at 7th grade. And here you, the reason we use the real numbers is because there's things in the rationals that have a sequence of rationals that have limits. So you have to, it's getting you ready for calculus. The real numbers are going to be limits of sequences. So square root of 2 is the limit of a sequence, but square root of 2 is not in the rationals. Pi is the limit of a sequence, but pi itself is not a rational. So you can actually take a limit inside Q and jump out of Q. So that's why it's unpleasant to work on Q, because you could just stop there and say, I don't need to actually go further. But the problem is you're getting students ready for 1950s math, which is calculus. In algebra, we call this a field. We talked about fields in linear algebra. And then you've got one more, and they don't talk about it much. But the problem with, so R is closed under taking limits, multiplication, division with the 0 removed, all of it works. But now you have simple algebraic equations that don't have solutions. X squared plus 1 doesn't have a root. So if you close up all the roots and say all those things that were missing roots and make that into a big box, that's the complex numbers. Closed under limits. We say it's algebraically closed. R is a calculus beast. C is an algebra beast. Oh, I don't know how to do that on here. Let me see if I can make it bigger. Nope, that's not it. I'll put it on the next page. Complex numbers. Closed under, we call it algebraically closed. We don't have really a real complex analysis. That's like an odd thing to say, a real complex number. We don't have a real complex analysis class here, I don't think. But in a complex analysis class, you learn all those things about algebraic closure. And the way I'm kind of teaching this class is we start with natural numbers and cool things about that, integers like number theory, and then we move from that to somewhere along the line we do some real analysis. So I give you like a toe dip into different areas of math. And then you'll see some of it. I've never done C as one of our areas, but we could. All right, questions? So that's all of your math education. That's it, all in 5 minutes. So you have to throw out the, what we call the additive identity, because you can't divide by 0.